Okay, rectangular coordinates or equations are written in terms of x and y, and polar equations are written in terms of r and theta. So this would be like r and theta, okay? And this would be in terms of x and y. So x and y. Some of the important equation conversions that we can remember is that x is equal to r cosine theta, y is equal to r sine theta, x squared plus y squared is equal to r squared, and then y over x is equal to the tangent of theta. So all of this side are written in terms of polars, and all of this left side is written in terms of x and y, or rectangular. So we're looking for substitutions we can make so that we can turn our rectangular equation into a polar equation, so in terms of r and theta. So the first one, x squared plus y squared is equal to r squared, so we're written in terms of x. We have an x and a y here, and I want to write this in terms of r and theta. So I'm going to go ahead and look to see from my little equation bank over here, is there anything that I can replace? So x squared plus y squared is equal to, this part right here, is equal to r squared, right? So I know that r squared is equal to 4. And I'm done. That's it. That's my equation. Okay. Oh, actually, just kidding. Let's solve. So square root both sides. I get r is equal to 2. Okay. If I were to draw that on the polar grid, well, r is equal to 2. So no matter what the angle is, I would always be at a radius of 2. So it'd be like a circle. Okay? At 2. 2. 2. 2. Okay, next one. Y is equal to 3. So I'm going to look into my little equation bank over here, and I'm like, ooh, what can I replace y with? Oh, it looks like I can replace y with r sine theta. Okay, so I'm going to be like, instead of y, I'm put r sine theta is equal to 3. Then I just have to solve for r. So r is equal to 3 over the sine of theta. We don't really know what that looks like, so we're just going to leave it like that. We're in terms of sine and cosine. Or sorry, we're in terms of r and theta. Okay, so we're a polar equation. Next, we're going to convert from polars, so in terms of r and theta, to in terms of x and y. So I have r is equal to 3 sine theta, and I have an issue because none of those look like my little bank here. So I'm going to have to, let's see, took an extra little line with us. That's okay. Okay. We're going to have to manipulate our equation a little bit. Okay. So r time equals 3 sine theta. I'm going to go ahead and think like, okay, I have nothing here that's just plain r, and I have nothing here that's just plain theta, but I have an equation that has r squared, and I have an equation that has r sine theta. So what if I multiplied both sides by r? I get r squared is equal to 3r sine theta. And then I remember that r squared is equal to x squared plus y squared, and that r sine theta is equal to y. And then we go ahead and I'm going to get the x and the y's on both sides. So x squared plus y squared minus 3y is equal to 0. And that's it. I'm in terms of x and y. Okay. For r, so this multiplying by r is not the only trick. In this case, if I multiply both sides by r, I get r squared is equal to 2r. And I'm like, okay, well, this side is good because I can replace that with x squared plus y squared. But on the right side, I have nothing to replace just a plain r with. So this multiply by r is not going to work. I'm going to try something else. Let's see, r is equal to 2. Okay, what else could I do? As long as I do it to both sides, I'm going to be good. So, how about if I just square both sides? Because I'm looking for an r squared, and I don't want the other side to be have an extra r. So I think this will work. I get r squared is equal to 4, and r squared is x squared plus y squared, which is equal to 4. That looks like a circle to me, okay? Which I think it is, because in polar, an r equals 2 is just a circle. Okay. All right, our last one. It's kind of just an extra. Plot the point and find two polar coordinates for the rectangular point. Okay, so this is just a little extra practice. Remember, this is an x, comma y. So we're trying to convert to r and theta. Okay, so I'm at the point 0, comma 1, 2. And I can see by looking at this that the angle at the top here is pi over 2, and that the radius, since it's going just straight vertically, is just 2 still. So the polar point would be 2, comma pi over 2. The work for that, if you want to show that, is r cosine theta, comma r sine theta. Okay, so I get the r is I did something funny. Yeah, I did something funny. Okay, so pause right there. I gotta go turn my coffee off. Okay, I'm back. Okay, so to solve for r, I would be like r squared is equal to 0 squared plus 2 squared. So r squared is equal to 4. So r is still equal to 2. Cool. We kind of knew that. And then the tan inverse of y over x, so rise over run, is 2 over 0, which is equal to theta. That is undefined, and so I know that theta is equal to pi over 2, because that's where tangent is undefined. Let's see. So we took care of the plotting the point. Find two different polar coordinates. Okay, so this is one polar coordinate. Just think about what is another way to write this polar coordinate. I'm going to go ahead and use, what if we were facing the 180 degrees from pi over 2? So 3 pi over 2. So I'd be facing downward. So I'm going to have to move back -2. There's an infinite number of answers. So if you got something different, go ahead and write it into the question. Okay. All right. Last one. 1 comma, nope, just kidding, -1 comma 1. So it's -1 comma 1. Now the polar coordinates overlie on top of this xy plane. So I'm going to attempt to draw a grid in here. We never draw it like this because look at what a mess this is. Okay. Okay. So I'm going to go back one and up one right there. And you're like, that is not on one of those circles. Not exactly on one of those circles. So the radius is going to be some non-whole number. We can solve for it though. So x squared plus y squared is equal to r squared. So -1 squared plus 1 squared is equal to r squared. This is r squared is equal to 2. So r is equal to the square root of 2. Okay, let's do the tangent. Tan inverse of 1 over -1 is equal to theta. So tan inverse of -1 is 45, or theta is equal to pi over 4. Negative pi over 4, excuse me. Again, that's in the fourth quadrant. So how do we get it into the second quadrant? We add pi. So theta is equal to 3 pi over 4, or add 4 pi over 4. Okay. So our polar coordinate with positive radius is √2, comma 3 pi over 4. If we're 180 degrees from that, we can use our original angle. So if I'm negative pi over 4, so if I am negative pi over 4, so facing this direction, I'm going to have to walk backwards to get to that point. So it's going to be negative √2. Again, there's an infinite number of answers here, but those are some quick, easy ones to find.